First, we will do a Lewis dot structure for the covalent bond C3H8 or propane. Carbon has 4 valence electrons, and we have 3 carbon, making a total of 12 valence electrons. Each hydrogen molecule has 1 valence electron, and we have 8 hydrogen, so we get a total of 8 valence electrons. We then add these two outcomes to get a final total of 20 valence electrons. We line the 3 carbon in a row, and then we put the 8 hydrogens around them. Then a line representing 2 valence electrons will be put in between each hydrogen and carbon until all the valence electrons are used up. To check our work, if we divide our 20 valence electrons by 2, we would get 10 bonds. As you can see, we have 10 bonds in this picture. Next, we will do the phosphate ion. Phosphorus has 5 valence electrons, oxygen has 6 valence electrons, and since we have 4 oxygen, we get a total of 24 valence electrons, and the -3 at the top counts as 3 extra valence electrons. If we add 5 plus 24 plus 3, we should get a total of 32 valence electrons. To begin the structure, we'll put phosphorus in the middle. Then we will put the 4 oxygens surrounding the phosphorus. We will make a chemical bond in between each oxygen and the phosphorus. Then we have to fill the octets of the oxygen and use the remaining 24 valence electrons. We will put 6 dots around each oxygen molecule to represent these electrons. You may think we're done, but if we look at the charges of the molecules, you'll see that they do not properly add up to a -3. We can fix this problem by taking 2 of the valence electrons from one of the oxygen and creating a double bond between the phosphorus and one of the oxygen. Now if we look at the charges, the phosphorus will have a charge of 0, one of the oxygen will have a charge of 0, and 3 of the oxygen will have a charge of -1, representing the -3 at the top of the phosphate ion. To finish this Lewis dot structure, we will put brackets and a -3 around the original structure to show that it is the phosphate ion.